Alright, so we're going to start with our foldable that says distance formula and midpoint formula on it. Today we are filling in the distance formula section. So on the front, the distance formula, we have d equals, and then we have one large square root. And underneath that square root, we have, in parentheses, x2 minus x1 squared plus, in parentheses, y2 minus y1 squared. And all of that is underneath the square root, and that is the distance formula. So let's take a look at the first example inside. So inside it says, find the distance between points A and C. All right, so A is at 3, negative 7. So just to help you out here, that is 1, 2, 3, and then I'm going to call this negative 7. And then C is at 0, 3. So I'm going to now label them x1, y1 and x2, y2. All right, so it doesn't matter which one's x1, y1 or which one's x2, y2, just commit and write it down. So now I'm going to go ahead this time and write out the distance formula so we can see where the numbers plug in. So I'm just going to rewrite it. It's on the left side of your foldable. You can see it right there. And we're just going to copy it down real quick. All right, so let's start plugging some numbers in. So I'm going to go ahead and fill in all the pluses and minuses, parentheses. And I'm going to use the highlighter. I'd encourage you to also so that we can see, okay, there's x2, and x2 is 0. So that's where we're going to go ahead and put 0. And so then I'm going to switch colors real quick. And minus x1, and here's x1, which is 3. So 0 minus 3. And then we're going to have y2. So let's go find y2. All right, that is 3 right here. So I'm going to plug a 3 in for y2. And then minus y1. And I'll tell you, this gets a lot easier just after you've practiced using the formula a couple times. It doesn't always feel quite so time consuming, just the initial time's a little tricky. So y1 was negative 7, so it's minus negative 7. All right, so from here, if you're going to type it in your calculator, then what I need from you for future problems, I promise you this will make it easier in the long run for other things we're doing. So if you plan to just type this in your calculator, only type what's underneath the square root in your calculator and then do the square root as a second step. And I promise you will see the reason why in future sections. So you'll have whatever's underneath your square root here. Let's go ahead and just do it by hand real quick to see what happens. So this first parentheses, 0 minus 3, that's negative 3. Negative 3 squared is 9. Negative 3 times negative 3 is 9. Over here, 3 minus negative 7, that's 3 plus 7, that's 10, and 10 squared is 100. Now, this is all still underneath the square root. I just haven't written it every single time just for the ease of fitting everything in. So I end up with the square root of 109. So now I'm going to type that in my calculator, and I'm going to just go ahead and round it off to 2 decimal places. That's just kind of a standard I like to do unless it says otherwise. So I get that it is approximately 10.44 units. Now I just want to show you another way to tackle this that some people in the past have really liked. So another thing you can do is you can create a right triangle between C and A. So let me get a color that'll show up kind of good. So just come straight down from C and then go over to A and then draw on your hypotenuse. So your hypotenuse is the distance you're looking for. You can count and see that that's 3. So that's 3 units. And you can count here, and this is 10 units. So you can think of it like the Pythagorean theorem. I don't know if you remember it from past classes, but it's a squared plus b squared equals c squared. And so if you did 3 squared plus 10 squared, that's where the 9 right here come from, and the 100 right here. And you're still going to get 109 equals c squared. And then when you square root, that's where our 10.44 units comes from. So I'm going to show you this way again on an example, just so you have the option to use it. But the distance formula directly comes from the Pythagorean theorem. All right, let's look at example 2 on our foldable. So we have our points. They're not graphed or anything. So we're just going to call this one x1, y1, and this x2, y2. So now in our formula, it's x2, which is -3, minus x1, which is -1, squared. Then it's plus, and it's y2, which is -4, minus y1, which is 4, and squared. So remember, from there, if you want to type it in your calculator, I am completely fine with that. Just make sure you're real careful with all your parentheses and signs and everything. But do not type the square root in at first. Just type everything underneath in your calculator. So if you want to, just make sure that you use all the parentheses, all the negative signs as it shows here so that you don't have a mistake in typing it in. And so I find out that that is 68. Oops, I'm sorry, switch back to the pen here. So that's 68. Now your answer is not 68, it's square root of 68. And then our approximation when I type in the square root of 68 is 8.25. And later we're going to simplify radicals, and we'll need it from this square root of 68 step. That's your exact answer. So when they want an exact answer, we're going to be taking that answer and simplifying it down. And this is your approximate answer because it is rounded. So we'll need the exact answer later. That's why I want you to do it in the 2 steps, because in the future you'll already be trained in the right habit and it will be a lot easier. Okay, so let's go ahead and try example 4a. This is in your 1.3 notes. And I'm just going to call Q x1, y1 and P x2, y2. So you can do this by making a right triangle out of P and Q. That's one way you can do this. So if you do that, this side is 3, this side is 1, 2, 3, 4. So then I could go in and I could use my Pythagorean theorem, and I could do 3 squared plus 4 squared equals c squared. That'd be 9 plus 16, which is 25. And then the square root of 25 is 5. Now let's also try it with the distance formula. So what would go in this first parentheses right here? All right, so if you do x2 minus x1, what would go in is 1 minus 5. So there's your -4, and -4 squared is 16. So now, what would go in this parentheses right here? All right, so we'd have 3 minus 6, and 3 minus 6 is -3, and -3 squared is 9. So hopefully you see the similarity between this step. You had 9 plus 16, and here you also have 16 plus 9. So you end up with 25, but keep in mind that this square root has been here all along, just sometimes I don't end up writing it on each step, which I really probably should, and the square root of 25 is 5. So the distance formula and the Pythagorean theorem are directly related. You could do it either way. The distance formula is going to be really handy when you have decimal points, so they're not whole numbers. If you have like 3 and 4.7, well, that's going to be really hard to graph accurately and figure out. So the distance formula would be handy there. It's also handy if you don't already have a graph. But if you do have graph paper and the points are already graphed, then the Pythagorean theorem is a great approach also, but they are directly related to each other.